Alright guys, welcome back to another exciting video here. I'm going to try to keep it short, under 20 minutes, so we're going to jump right into it. Today we're going to talk about arc lengths and areas of sectors, okay? So we're going to start out with sector areas, and to do that I actually want to start out with a formula you may remember from the middle school, which is area of a circle, which I'm sure you're all familiar with, but just to remind you that the area of a circle is equal to A equals pi r squared. And remember, r stands for the radius. So there's really only one variable when it comes to the area, and that is your r value, or again, the radius, right? The radius. So a sector area, or a sector of a circle, is basically a slice of the area. Now let's see how good I can do a circle on the iPad. Not terrible. In a sector of a circle, it's probably easier to show you than to define it, although I'll do both. If I draw a circle and I maybe carve out a slice, right? My sector, or my area sector, would be the portion of the area inside that slice. So that would be what we would call the sector area. And if you're someone who's into definitions and things like that, I could define sector area as the region, okay, of a circle bounded by two radii with two eyes, and an arc of the circle. Okay, that's the formal definition. If you were to look CIR, not CRIL, how do I do that? CIRCLE. That's your textbook definition. You don't need to know the textbook definition. If you just understand, hey, it's just a slice of the area, you'd be good there. So the question is, how do we find the area of a slice? It's actually pretty simple. So let's take an example where I have a circle, okay, and the radius of this circle, I don't know, we'll call it, we'll call it 6. And let's say we want to find the area of a sector whose central angle, okay, is 100 degrees. So the central angle in here is 100 degrees, and I want to find the area of this slice right in here. So we know a circle has 360 degrees. So basically what I'm trying to find is the area of a sector whose central angle is 100 degrees compared to the 360 degrees in a circle, right? All I'm going to do is set up a simple proportion. If I want to find the area of a slice that has 100 degrees compared to the 360 degrees, I can set that equal to my sector area, the area I'm trying to find, over the area of the entire circle, which we know to be pi r squared, which in this case is 6. So I did a simple proportion. 100 degrees to 360 degrees should be the same as the sector area to the entire area, right? Setting up a simple proportion. So in that case, we would cross multiply, right? So we would do pi 6 squared times 100. Maybe I'll write it out. So 36 pi times 100 divided by 360 should give me my sector area, which, if you have a calculator, pi, if you remember, equals 3.14. Now, some calculators might have a pi button, some might not. If you have a pi button, use that. If you don't, you can use 3.14. And you would multiply all that out and divide it, and you should get 31.42, in this case, units squared. It's squared because we're finding area, right? So we're finding area. So all we're doing when we're doing sector area is setting up a proportion, right? So in general, if we want to come up with a general formula here, it's pretty straightforward. All we're going to do is take my central angle whatever that is, over 360. We're going to set that equal to your sector area over your area of the circle. Okay, now typically you're going to be given the central angle. You're always going to have 360 in the denominator. You're going to be given that, you'll be able to find the area of the circle, and then you have to find the sector area. But in reality, I can give you any of these 3 of the 4 pieces, and you find the 4th piece. So it's possible, maybe on a more difficult problem, where I give you the sector area, I give you the area of the circle, and you have 360, and you have to find the central angle. As long as you have this general formula, you should be able to fill in any of the 3 of the 4 pieces, and then be able to find your 4th piece, okay? So let's maybe try to find an example of that. So if we go to the next page and we go to the second one down, now you can do the first one that asks you to find the area of the sector formed by UTV. Feel free to do that on your own. The solutions are on Canvas. But let's try to do one that's a little bit different than the one we saw above. And I encourage you, if you want to give it a shot on your own, to pause the video and see if you can figure out the answer to this, the area of the circle. But if you want to work it through with me, that's okay too. So here's what we have. It says, use the diagram to find the area of circle V. And what they give me is my central angle, right? My central angle being the 40 degrees. It gives me the area of the sector, and it's asking me to find the area of the circle. So if I set up my formula just like I did above, okay, I know it's always going to be central angle, which in this case is 40. Okay, so 40 over 360 should be equal to the sector area over the area of the circle. I don't know the area of the circle, but I do know the sector area is 35 degrees, or excuse me, 35 meters squared, and I want to find the area of the circle. So in this case, I'm going to cross multiply. I'm going to do 360 times 35 divided by 40. That's going to give me my area. And if you have your calculator, the calculator would give you 315 meters squared. Okay, so pretty simple to set that up. All right, the next problem is a little bit more of a challenge. I would say if you want to take that on, feel free to do it. In the interest of time, I'm not going to do it now. But it's a good word problem. I'm sure you're asking, Mr. Bonner, could something like that be on the test? Sure, it definitely could. So maybe when we're back in person next week, we'll go over this one. Or if you want to give it a shot on your own, feel free to do that as well. But I want to jump into now arc lengths. Okay. So let's do some arc lengths here. And let's remind ourselves, before we get into arc length, what the circumference of a circle is. A circumference is simply defined as C equals to pi r, again r being the radius. And the circumference, just to be clear, if I draw my circle, I don't know if you can hear the baby crying in the background, that's the joys of teaching from home. If you can't hear it, you should be thankful. The circumference, right, is just the length. Now notice the length of the circle on the outside. I'm not talking about degree measure, I'm talking about length, right? So imagine a piece of string going around the outside of the circle and then measuring that string on a ruler. That is the arc length. So there's a difference, right? So I just want you to remember this difference between arc measure, that's what we've been talking about before this class, versus arc length. Arc length is just what it sounds. It's the actual length of an arc, not the measure in degrees. So that's circumference. Circumference is like all the way around the circle. So arc length specifically is just a portion of the circumference, right? So, for example, maybe I have a central angle here, and it forms an arc. The arc length would be the portion formed by that central angle. So that portion in green would be my arc length. And I might just simply define that as a portion portion of the circumference of a circle. That's simple. So let's do an example. Luckily, or nicely, it follows a pattern very similar to the sector areas. So let's do an example where I draw a circle. There's my circle. And let's draw in, oops, didn't mean to do that. Let's draw in a central angle, where that central angle is 50 degrees. Put in some letters here too, B, C, and let's call the radius, I don't know, maybe 8. What I want you to do is find the length. Now notice I didn't say measure. The measure of arc BC would be 50 degrees, but when I say find the length, I want to find that portion of the circumference. So find the length of arc BC. It can be a little bit confusing. The measure of arc BC, just to be clear, would be 50 degrees because it's going to match our central angle. But when I say find the length, I will actually want the length, right, of that portion of the circumference. So I'm going to encourage you to pause the video, see if you can figure out how to set up a problem that would that would allow us to solve for arc BC. So try that, and then follow along with my solution here in a minute. All right, so hopefully you tried it. If you didn't, shame on you, but that's okay. I'm going to set it up similarly. If I have a portion of the circle that's 50 degrees, I'm going to do 50 degrees over 360. That should be equal to my arc length over the total arc length, which is just the circumference. So it's equal to BC over 2 pi r, which in this case is 8. So if I cross multiply and divide, I should be able to do 16 pi, which is 2 pi 8, times 50 over 360 should be equal to the arc length of BC. And if you do that out, you should get, if we round to 2 decimals, 6.98 units. And since it's not an area, it's a length, we're not going to do squared units, right? We're just going to do linear units. So in general, similarly to the sector area, to find the arc length, it's just going to be central angle over 360 should be equal to your arc length over your circumference. Okay, that's simple. And much like with sector area, I can give you any of the three of the four pieces, any three of the four pieces, and you should be able to find the fourth piece. So I could give you circumference, the 360, and the arc length, and you would have to find for the central angle. You would have to find the central angle, for example. But again, as long as you have three of the four, you should be able to solve for any of them. So let's maybe do one example together. If we go to the next page, let's skip those first three. And let's do part A on the second piece where it says, find the circumference C of circle Z. So again, I would encourage you to pause the video, see if you can solve for the circumference, and then see if your answers match mine. Okay, so hopefully you gave it a shot. Quickly, central angle is 40 degrees, so 40 over 360 should be equal to my arc length over my circumference. I'm given the arc length, it's 4.19. I don't know the circumference, I'll just call that C. From this point, we just cross multiply and divide. So 360 times 4.19 over 40 should be equal to C, which if you do that out, comes out to 37.71, in this case, inches, or it's not squared, inches. Okay, so very similar to sector area, and our arc length is very similar to sector area. Both are I think, are pretty straightforward. This is a good day for me to be missing, I think. If you feel like you need a little more practice, do some more practice of these on your own. The solutions are on Canvas. When you're done, you feel like you're ready, feel free to start on the homework, which is the circled problems from worksheet number 11. It's only 4 problems. They're a little bit involved, but I think it should be manageable. And given we're only at 15 minutes for this video, you definitely should be able to finish it up in class right now. So good luck with that, and I look forward to seeing you guys next week.